In this lesson, we're going to discuss continuity. So first off, what makes a function continuous at a point? A function is continuous if three criteria are met. The first is that the function is defined at that point. The second is that the limit of the function exists at that point. And the third is that both of those criteria lead to the same number. So the function value is equal to the limit at that point. So let's take a look at a few graphs and decide whether those graphs represent functions that are continuous. So is this graph continuous throughout its domain? So in order to determine if a function is continuous throughout its domain, we're going to go through those three criteria. Does the function exist at every point in its domain? Does the limit exist? And are they the same value? So we notice right away that f of 1 is undefined. There's a hole at that point, so there's no function value there. Because there's no function value there, it violates that first criteria for continuity, which implies that f is discontinuous at x equals 1. In this next example, we see that we have a piecewise defined function. So again, we're going to look at, is the graph continuous throughout its domain? Well, the first criteria is met. There is a function value at where that split is in the function. So f equals 1 is about 1.5 looking at the graph, so that criteria is met. The second criteria is there a limit there? So if I look at the limit as x is approaching 1 from the left, it's at about 1.5. But if I look at what the limit is as x is approaching 1 from the right, well, that's at about 3. Well, because those are two different values, the limit does not exist. Because the limit doesn't exist, this function is discontinuous at x equals 1. It violates that second criteria. In this third example, again, we have a function here. This function has a stray point there. So again, we're going to go through our three criteria for continuity. First criteria, does the function value exist at 1? Yes, it does. At this point, this is part of the function, part of the graph. There is a function value. So again, this is a piecewise defined function. One part is just a point. The second part is this curve here. Second step, does the limit exist? So the limit, if I'm looking at this function here, the limit as x is approaching 1 from the left is at about 2. Approaching 1 from the right is also at about 2. So the limit does exist because the limit as x is approaching 1 of my function is equal to 2. So second criteria is met. However, the function is discontinuous because the function value is not equal to the limit. So we are discontinuous at x equals 1. So just to review, what makes a function continuous at a point? It's continuous if it is defined at that point, if the limit of the function exists at that point, and if the function value equals that limit at that point. So if I were to have a function where my function value here was 1 and all these limits were also 1, well, then that would be a continuous function. Kind of in layman's terms, a function is continuous if there's no holes in the graph, like we saw in this first example. If there's no jumps, so this was called a jump discontinuity here for that second example with the piecewise defined function. So we shouldn't have any jumps. And the last thing that we shouldn't have is any asymptotes or stray dots, as we see here. So if I have a nice smooth curve that I can draw without lifting up my pencil, that's kind of the quick visual, is this continuous? But in order to actually prove mathematically that a function is continuous, we need to make sure that we can fully support these three criteria.